Hi everyone, today we are going to talk about 12.8a, confidence of interval with margin of error. So we are going to understand what a confidence interval means and compute margin of error by identifying sample size and create a confidence interval by using the sample proportion and sample size. Let's see, what is a confidence interval? Confidence interval refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. So this confidence interval measures the degree of uncertainty or certainty in a sampling method. It's not the probability, all right, of the sample. It measures the degree of certainty or uncertainty in a sampling method. So they can take any number of probability limit, with the most common being a 95% or 99% of a confidence interval level. So if the researchers want even greater confidence, then they can just expand the interval to the 99% of confidence. So if you have a greater interval, then you are more confident, right? That's kind of meaning. So let's see with the example. A political pollster plans to ask a random sample of 500 voters whether or not they support the incumbent candidate. The pollster will take the results of the sample and construct a 90% confidence interval for the true proportion of all voters who support the candidate. Which of the following is an incorrect interpretation of 90% confidence level? We have three choices here, A, B, C. Two of them are correct, but one of them is incorrect. Which one is incorrect? A, if the pollster repeats the process and constructs 20 intervals from separate independent samples, we have 20, you construct the 20 intervals, then we can expect that about 18 of them to contain the true proportion of voters who support the candidate. B, about 90% of people who support the candidate will respond to the poll. C, if the pollster repeats this process many times, then about 90% of the intervals produced will capture the true proportion of voters who support the candidate. Which one's answer? Which one is wrong? B is wrong, right? So A and C is correct. So confidence levels don't tell us the response rate of a poll. This is wrong. So while you are looking at these examples, I want you to be familiar with what is the confidence level. All right, let's see with the second example. A baseball coach was curious about the true mean speed of fast ball pitches in his league. The coach recorded the speed in kilometers per hour of each fast ball in a random sample of 100 pitches and constructed a 95% confidence interval for the mean speed. The resulting interval was 110 through 120. Which of the following is a correct interpretation of the 95% confidence level? Now, two of them is correct, one of them is wrong. So A, if the coach took another sample of 100 pitches, there is a 95% chance the sample mean would be between 110 and 120 kilometers per hour. B, about 95% of pitches in the sample were between 110 and 120 kilometers per hour. And C, we are 95% confident that the interval 110 and 120 captured the true mean pitch speed. So which of the following is the correct interpretation? C, right? So A, confidence intervals give us plausible estimates for population parameters. They don't make estimates about upcoming values of sample statistics. B, why is wrong? Confidence interval don't show the distribution of sample data. They do give us a plausible estimates for population parameters. So C is correct. We are 95% confident the interval captured the true mean pitch speed. So a confidence interval gives us a range of plausible values for a population parameter. The last example. Suppose that the coach from the previous example decides they want to be more confident. The coach uses the same sample data as before, but recalculates the confidence interval using a 99% confidence level. So 99% from the 95%. How will increasing the confidence level from 95% to 99% affect the confidence of interval? Choose one answer. It is impossible to say without seeing the sample data. B, increasing the confidence will increase the margin of error, resulting in a wider interval. C, increasing the confidence will decrease the margin of error, resulting in a narrower interval. Answer is B. So A, changing the confidence level impacts the margin of error. Margin of error is how many standard deviation away from the mean, right? Margin of 1 standard deviation, what 2 standard deviation, what 3 standard deviation from the mean. So that's the margin of error. How many standard deviation away, the distance from the mean. I will explain again. And so B is the answer. Increasing the confidence will increase the margin of error, resulting in a wider interval. So a larger margin of error produces a wider confidence interval that is more likely to contain the parameter of interest. Increase the confidence, not decrease, right? So how is it? So now today, I'll give you how to find out the intervals of confidence of interval, right? You should know what is the margin of error. The confidence of interval is a range or interval of values used to estimate the true value of population parameter. So, you know, the X bar is a mean, but from the sample mean, right? Minus margin of error. So just know the how many standard deviation plus margin of error. So the distance from the estimate X bar means the sample mean of the sample to one end of a confidence interval. So that's the margin of error. So margin of error 95% is a 2 standard deviation, 68% is a 1 standard deviation. All right. And then 3 standard deviations, how many percent? 99.7% you are competent of. So let's talk about it. So you will see like this symbol is the mean from entire population. So entire distribution, which is we call population mean, compared to versus this one is the mean from the sample. This is a standard deviation from the population or entire distribution, but this is a standard deviation from sample. All right, just be familiar with the symbols. You know the small sample, the entire population. So let's get the example, one example. Young-ho prefers to jog 3 miles. From experience, he knows that his jogging times produce standard deviation from entire population is 2.4 minutes. 2.4 minutes. For a random sample of 90 jogging sessions, the mean running time was, so this is the sample mean, the mean from the sample. So 22.5 minutes, 50 minutes. So let mean, this is a what's that? Mean from entire population. This is the mean from sample population. So let mean be the mean jogging time for the entire distribution of all those actually not ideal. So Young-ho, sorry, 3-mile running time over the past several years. Find the 95% confidence of interval for mean. So 95% of confidence of interval. You know, confidence of interval, how do you get it? Mean minus 2 standard deviation through mean plus 2 standard deviation, right? So we are done. So let's this. This is the mean, 22.50. And population mean is 2.40. Okay, one more time. I will show you the standard, the deviation 2.40, right? Then how do you get the confidence interval? 95% confidence interval for mean. This mean is from the entire population, entire distribution, which is population mean. So interval for this entire the population mean can be the sample population mean minus 2 standard deviation through the sample mean plus 2 standard deviation. So it'll be like this, right? 2 standard deviation 4.8. So you minus plus, you will get, this is the interval, 17.70 through 27.30. So simply, when you get the confidence of interval, margin of error for 95% is 2 standard deviation. So you subtract 2 margin of error from the mean, and you add margin of error to the mean. That's the interval. Simply, you get it? So how do you state? We are 95% confident that the interval from 70.70 to 27.30 contains the true average running time for a 3-mile run. All right. So please note that this is a correct statement. We are 95% confident that the interval from here to here actually contains the true average running time. We are 95% confident. But be careful, this is incorrect statement, this one. There is a 95% chance, 95% of probability that the true average running time is 17.70 and the 20. That's a completely different story, all right? So this is incorrect statement. This is a correct statement. So one more example. Some smartphone applications contain in-app purchases, which allow users to purchase a special content within the application. A random sample of 140 users found that 35% made in-app purchases. A simulation was conducted with 200 samples of 140 users, assuming 35% of the samples make in-app purchases. The approximately normal results are shown. Considering the middle 95% of the data, 95% of the data, determine the margin of error. You know the margin of error to the nearest 100th for the simulated result in the given. If you look at here, there's a mean is 0.35, which is 35%, right? And SD means sample standard deviation is 0.042. So mean is 0.35. Now how do you find out to determine the margin of error? Margin of error is what? 2 standard deviation, right? 2 standard deviation. So where's the standard deviation? 0.042, which is 4%. Here is 4%, so 4.2%. But 0.042 is the standard deviation. So mean is 0.35. So margin of error is 2 standard deviation, is 2 times of a standard deviation, 0.042, which is 0.084. And to the nearest 100th, we round, so it will be 0.08. For smaller than 5, we'll throw it away, right? So 0.08 is the margin of error. That's the answer. And what is how do you get the confidence interval? So 0.35 is the mean, and you subtract the margin of error, you add margin of error. So lower level, lower bound, upper bound, higher bound. So 0.27 through 0.43 will be the confidence interval. So margin of error of 0.08 means that 27 to 43% of users are expected to make in-app purchases. All right. So we'll stop here. Okay. Stop here.